Hello everyone, welcome to NIS341, a deep dive into Amazon VPC Lattice granular security. I'm Pablo Sanchez. I'm a network specialist solutions architect based in Madrid, and with me I have Cristobal.
Hi everyone, I'm Cristobal Lopez, also a solutions architect on AWS based in Madrid. I work with finance customer and with main focus on networking.
Okay, so you have two networking guys up on the stage, but let's see what's the audience. So how many networking people we have? So raise your hands. Okay, good number, good number. How many platform people, so kind of infrastructure in general, several count, okay. How many security people? Of course. And how many of you will say you have several hats, like you do a couple of them? Okay, so that's good. Yeah, everyone, definitely. So yeah, of course, like this, with this session, we also want to discuss VPC Lattice with the idea of how you can, with those several hats, help you simplify your environment on AWS, plus also adding this granular security. So the agenda for today, this is a code talk. How many of you have been in a code talk before? Raise your hands. So not so many people, so yeah, I'll do a quick intro on the session. You know Chol Talk, where we have a whiteboard and then we talk about a specific architecture. Here is going to be more or less the same, but we are going to be coding live that architecture. We will share related code, not exactly the same, because we have a front end, back end, so we wanted to show you some code that is simpler. But we will share some code so you can check it if you want to during the session, but we will be doing some code. We won't be waiting for anyone to code live with us. We'll just simply be doing it. But then we want to be a conversation. So while Cristobal is going to be coding, I'm going to be chatting with you downstairs so we can have a kind of like an architecture session, but well, we code it live. Before we start with that, we wanted to do an intro on VPC Lattice and then how security works. And once we do it, we try to make it as fast as we can. We will explain the use case, and we will go directly to the coding. So let's start with an intro on VPC Lattice.
Yep. Thank you, Pablo. So as he was saying, first we're going to do a 101 on VPC Lattice, so everyone's on the same page. How many of you have heard of VPC Lattice before?
Okay.
Almost
nice.
Everyone. How many of you have played or implemented, let's say, in development, the service? Few less, and in production?
We have one brave one there.
Nice.
Okay.
Nice.
That's why we're here.
That's why we're here, indeed. So when it comes to VPC Lattice, we're going to go through the main components that we have on the service. Let's think about the AWS cloud, and within the region, what you have first, the main component that we can see is the service network. Think of it as the switch in which you can are going to the network in which you're going to have on the one side the consumers that are going to be consuming the different services that you want to expose, and on the other side you're going to be having the services that you want to have exposed for the different consumers to make use of. And so here we have an example of a compute unit or a service. In this case, it's an ECS cluster. We'll get into the different types we can have, but almost any kind of compute on AWS. And we can create the figure, let's say, of the service, VPC Lattice service, that is going to be this unit of compute within the service. And it's going to have a target that is going to say like where we're pointing to. When we create a service, a custom domain name is going to be created automatically for us to be able to communicate to the service. But if we don't want to use just the main one that is created, like the default one that is created, we can also use custom domain names. And in order to integrate the custom domain name with whatever we have on AWS, like for the communications, we're going to be able to integrate it as well with Certificate Manager. So that's another integration we have with the different services on AWS for this. And between the service and the service network, in order to expose the service in the service network, we have what is called the service association. And on the other side, not only talking about the services exposed, we have the consumers. In this case, we have a VPC with some resources on it that are meant to be, in this case, the consumer of the different services that we have on the service network. And in order to give access to the VPC to the service network, we have the VPC association. And in order to access to the VPC association through the VPC, what we have is, well, like in many other cases that you see, the security group in which we can start applying some security, and we can have the access to the service network through a non-routable IPv4 on the VPC, and also arranged on the IPv6 network. And in order to be able to access through the resolution, we will have to have this, in this case, what we're using or what we see most commonly is a private hosted zone in order to have the domain. That can be either the custom domain or the default domain that we're going to use. And then, so when a resource is trying to access a service in VPC Lattice, it's going to do the resolution, and then it's going to access through the service network and end up accessing the service that we are exposing in the VPC Lattice service network. So as a summary, we have the VPC Lattice service network. We have the unit of compute that is the VPC Lattice service, and they're connected through the association. And this unit of compute can be either EC2, EKS, ECS, or containers, Lambda, IP targets. So we have all the different kinds of compute that we can have. Also, the communication can be through HTTP, HTTPS, gRPC, TLS pass-through. We have different options. When it comes to not only accessing through HTTP or HTTPS to the units of compute, we also have TCP communications. In this case, it's through resource associations, and the end targets can be either there's a direct integration with RDS, for example, for databases, but we also can have any kind of IP DNS on the other side. And regarding the consumers or the clients, remember that for the regional consumption, we have the VPCs with the VPC association. And for the cases in which we want to have a multi-region or hybrid access, we do that through a VPC endpoint that we have on the VPC that allows us for more flexibility and accessing in different scenarios. But this is just the communication. Now we're going to get into the security part of VPC Lattice. And for that, Pablo, the stage is yours.
So we have said how we simplify things with VPC Lattice, but now how security it's in place, because of course, like with VPC Lattice, you enable simplification of the connectivity, but you may want to have some granular controls on that communication. So the same main principle on VPC Lattice is the concept of zero trust. So basically what we want to do is not only provide security by the place in the network where the consumer and producers are created. Also because on VPC Lattice, you can have overlapping CIDR blocks. You can have IPv4 on one side, IPv6 in the other one. So right now, it provides some of simplifications where if you only get the IP to have that communication, you're losing a lot of control. But also, we want to have control in terms of who the service are that wants to consume another service, and if they have access or not. So the idea is like if we have identity-centric security and network-centric, imagine identity-centric like an IAM role when an EC2 instance wants to consume an S3 bucket. Ideally, what you want is to have both controls together and aware of each other, and that's what we're going to try to do with VPC Lattice. So for that, kind of same architecture as we have seen before. As Cristobal said before, the minimum security controls, you have micro-segmentation at the consumer and at the producer with security groups, but then you can configure policies both at the service network and at the service level. We will discuss later during the demo like an example on when to put policies or how to think about the policy configuration in each one of the resources. And what it's going to happen is our consumers will sign the request with SIG-before. We will see an example in the demo. SIG-before is commonly used, for example, to communicate to S3, so obtaining metadata about the IAM role, principal, organization of the resource, put it as a header, and then authenticate myself through the service, basically for the information of who I am. So with that SIG-before, we will put the headers, the signed headers in our request, and then traffic will go to the service network, will accept or not the packet. If it accepts the packet, so it will send it to the specific service that will accept or not the specific configuration. So we will just simply put information about who am I, and then both from the policy service network and the service will allow or not the communication. So that's the basic principle of security in VPC Lattice. So what are we going to show you today as an example on how VPC Lattice works, both in a security and in a connectivity point of view?
Yep. So regarding today's use case, what we're going to see, functional-wise speaking, what we're going to have is first a front end that you will all get access to. We'll share with you now a QR code to see that. We're going to have this front-end service communicating first with a backend that we have, backend one that we have running on EKS, and also it's going to be communicating to a backend 2 that we have running, in this case, not on EKS, but on ECS. And the different communications that we're going to have three different paths. The first one is going to be this local endpoint that is going to be just targeting backend 1. Then we're going to have the remote path that is going to access EKS, and then it's going to do an inherited call because backend 1 is going to be calling backend 2 from the remote call that is going to be receiving. And also, we're going to have the Lambda function doing a direct access call to the backend 2. And we will see the behavior of these three calls in the use case that we have. And now, in order to see while checking the architecture, I will start getting into the code while Pablo explains to you what is the architecture going to look like.
Yeah, so we are starting, that's our starting point. We're going to have the front end with the Lambda function. The Lambda function to be consumer needs to be in a VPC. To be a producer, it can directly be targeted by a VPC Lattice service, but we have it only today as consumer. And then we have the EKS cluster and the ECS cluster. First thing we're going to do, we're going to create our service network and associate the consumers, the VPC that are going to be consumers, which are the front end and the one where we have backend 1, which is the EKS cluster. ECS is going to be only producer, ECS is going to be only producer, not consumer. Once we have the consumers connected, we're going to publish our services, both on EKS and on ECS, and we're going to associate those services to enable communication. And then, of course, have the DNS resolution ready, so both the Lambda function and the EKS pods are able to resolve the different services. But with that, we're enabling communication, but we have some cybersecurity requirements. So basically, we're going to allow only authenticated requests. We don't want any communication outside the AWS organization. And also, as Cristobal said, we're going to try 3 connections, but we don't want the front end communicating directly with backend 2. We only want to do it via backend 1. So with that architecture, we're going to first apply a policy document in the service network, only allowing authenticated requests and from the organization that we are located. We're in a single account, but we have that account in one organization to show you that behavior. And then once we do that and we see that we don't have communication, we will sign the request in the Lambda function and the EKS service. And then once we do that, we will put another policy in backend 2, only allowing communication from the EKS cluster. So now we will see that the Lambda is not able to, even though connectivity is done, we have this microsegmentation done at the VPC Lattice network that we don't allow the front end communicate with backend 2. So with that, I think it's time to code, because this is a code talk, not just us talking. I'll leave you 2 minutes with this code. This is similar code. It's not exactly what we are building today, because this is it has more than just VPC Lattice, but you can see an example of a multi-account architecture with VPC Lattice. Take the link with you, because we will be updating this repo, creating a more complete blueprints on VPC Lattice. And for now, you have one example for today. So I think with that, I'll leave you a couple of minutes. I still see people targeting. No? Okay, so I think we're good to go. So, yeah, all good?
Perfect.
So before we go to the code itself, just a reminder, this is another QR code, which the front-end page where you are able to test anytime we're building stuff that the communication is happening, is not happening. So we will share this. We will show these slides later, so you can start getting the QR code if you want to. So this is the starting point, and now Cristobal will go to basically create, as we said, the VPC association and the VPC Lattice services. So the first part is going to be creating the communication. So with that, let's put the code ready. And while Cristobal is doing that code, I'll be explaining to you. But as I said, this is a code talk, so I'll be down around. So if you have any questions, raise your hand, and then we can have a chat while Cristobal is building everything. So yeah. So Cristobal, what are you starting with?
Yep. So the first thing, just to explain a little bit the project itself, as probably most of you are familiar with Terraform, infrastructure as code for deploying, in this case, AWS resources. When using infrastructure as code, normally what we recommend is making use of modules that are, in this case, the ones that we're going to be using are created and maintained by AWS. So you have the guarantee that it's us, the one that are creating and maintaining this code, and that we're trying to keep it updated every time with the new features that are released and everything. And so in this case, we have a project in which we have several Terraform files. We're going to be focusing just on 3 or 4, which are the relevant ones for us. But we have a lot of ancillary files as well, just for building the things that from the architecture that we're starting from. So like the VPCs, some networking resources, etc. And we also have the backends for the EKS cluster, and DCS. And in this case, in this file that we're at, which is the front-end router, in this case, you can see that we're making use of one of these modules that I told you, which is the VPC module in the AWS IA VPC AWS that you can find it. And in this case, what we're going to do is the association of the VPC with the service network. And that, thanks to the module that we're using and some of the properties that we can pass to, just by specifying the property of the service network, we're going to be able to create this association on the go.
Yep. So now basically what we're doing is, the VPC association, we include it as part of the Terraform module. It's only one resource in that case, but of course, like, you can include it in the creation of the specific VPC. As you can see, the VPC Lattice service network has been created with another module, in that case, a module for VPC Lattice, that then Cristobal, you would see as he will use this module to create the VPC Lattice service for the ECS cluster, or for the services that are on ECS. For EKS, most of you, of course, majority of customers would like to have everything on the Kubernetes side. So what we have is the Gateway API controller. So instead of the ingress controller, we have the gateway controller that will be the one creating the VPC Lattice service. So we will show that, not in detail, because we don't have enough time to focus on the part of Kubernetes, but we will show a little bit the code that does this configuration. So while Cristobal is building everything, in terms of what is the compute solution that you have in your environment, how many of you work with EKS? ECS? Okay, good, ECS. Lambda? Okay, and how many of you mix between those two services? Okay, so this is a nice example. So VPC Lattice really shines on 2 main use cases. If we have a cluster, containers, Kubernetes is cross-cluster within a cluster. Maybe it doesn't make any sense. Already Kubernetes or ECS, if you use Service Connect, provides you that functionality within the cluster. But when you do cross-cluster, VPC Lattice is a really nice solution. And also if you have different technologies, because you get agnostic to the compute capacity or the compute solution. And then if you need to exit the cluster, or if you are an EKS cluster talking with a Lambda function, for them it's just a VPC Lattice service. It's a DNS name that goes to a link local address or an endpoint IP. So you don't need to change the way services are consumed. So any questions, any doubts so far? Yeah, let me give it to you so everyone can hear you.
So I'm just saying that he's doing.
Try again.
Hello.
Can you? Should work.
Test.
Okay. No, if not, I'll repeat it. Don't worry.
So I'm saying that he's doing certificate arms and stuff and having listeners. So is this the portion too where it actually configures the load balancer?
So with VPC Lattice, you don't need a load balancer. The VPC Lattice service acts like a load balancer or an API gateway for the Lambda function. So it
configure listeners and target groups.
Exactly. So it's really similar, the experience, as if it were a load balancer. It's not, but we did it on purpose, so you don't need to kind of learn a new thing to target stuff. But it's exactly similar. So basically it's listener, target group, and different, like if it were a load balancer, but it's the VPC Lattice service itself. So and exactly. And as you were saying, like we also integrate with a certificate manager. We can put a custom domain name. In that case, as Cristobal mentioned, and then like from that listener, he will be creating the target and just saying like, hey, I want this target to be part of this listener. Then you would see that we're creating the target for the ECS cluster, but then the way it creates the targets is a native integration with ECS. So we will go to the ECS cluster, And then we will indicate that, okay, this is my target group, and this is the IAM role that I want you to obtain just to be updating the targets anytime you have a new container in the network. But yeah. Yep. Just tell you and then I'll repeat it.
How does VPC Lattice differ from Transit Gateway?
So Transit Gateways is IP level. So you communicate VPCs and then you target with IPs. So you just still need to create your own application communication on top of Transit Gateway. VPC Lattice is application communication. It just abstract all the network. So from the consumer point of view, they connect to a link local address, so they connect to something intrinsic or local to the VPC, and then we'll send the packets to the other side. So it's like two different use cases. They can live together. We have a lot of customers like having Transit Gateway for some IP level communication, but then any service to service, they abstract all the network. The only networking you need to really think when you work with VPC Lattice is HTTP, HTTPS, and DNS. And DNS is just like a database. You don't need much of a DNS configuration. And then you can work with both of them separately. Yep.
If you are using Lattice over like a Transit Gateway and the network layer, is it a net increase or a net decrease?
Things like you don't use them together. You just like to separate networks. What you're going to have is you're going to have your IP level network and then your application level network. So if you need to go to something that is published on VPC Lattice, you will go to the service network and to the service. And then if for some reason that specific application is not part of the service network, I need to go to an SD-WAN network because it's in on-prem, or I need to go to another VPC that is in the Transit Gateway, I will route to the Transit Gateway attachment. So it will be kind of like I have my VPC in the middle, and then I have my layer 7 network with VPC Lattice, or layer 4 network, and then my layer 3 network with the Transit Gateway network.
Because it sounds like it allows developers to avoid having to create a lot more complex IP level networking assets.
Exactly, yeah.
So is that, in the end, is that going to be a net decrease in spend, in cost?
We have seen decrease in cost. Definitely what we have seen in customers is operational, as you mentioned. Like now teams are just simply have my new application. I'll go next to you. I'll go for simply I have my new application, I'll publish in the network. In terms of infrastructure, it depends. It's true that sometimes if like we have seen a decrease in cost a little bit in the infrastructure, but at the end of the day, it's going to be instead of using Transit Gateway, we'll be using VPC Lattice. But then definitely the operational cost, yes. In cluster, where maybe I need to use an ad gateway because I need a secondary CIDR block, because I need a huge block for my pods and everything, that will be a reduction in the infrastructure. So in those cases, yes, but definitely operational is going to be a reduction.
One of the reasons that we see customers leverage something like Cloud WAN is for centralized network routing and inspection as well. So even east-west between shared services environments, it seems like this would be a good application for that. From a network security logging perspective, what are you able to capture as part of this? Because you're losing that east-west visibility if you're leveraging this bypassing your security.
So you're not losing it because you have logs at the service network and the service level. So you still know which is talking with what in an east-west. And I would say even you can get even more granularity if you're working with clusters. Because in a cluster, if you just pass it through a firewall, you have the IP of the pod or the container. You don't know who is doing that call unless you put extra metadata. Here, if you're signing the request, you know exactly that service X in cluster B is talking with service Y in cluster C. So you have still that visibility. So usually with east-west and Cloud WAN and a firewall, the question is more on what type of visibility and security you want to have. If you want to have really deep packet inspection, yeah, that model works because it simplifies the routing. You can have really deep level inspection capabilities in the firewall, and then you have the visibility as well. But if it's simple, like I want A to talk with B, and I want just to know when it happened, VPC Lattice gives you that simplicity without having to manage the firewalls and don't need to worry even on the overlapping CIDR blocks, on the size of the VPC of your cluster. But maybe you have some situations where you need it, so that's why I said like it's a parallel network. Yep.
Does the private link will not solve this problem because the VPC Lattice, the consumer and the provider both has to
I would say VPC Lattice is private link 2.0 because private link you need an NLB to publish your application, and then you need endpoints on the other side. So at the scale, you have a lot of NLBs that you don't need because you just simply want to target your application, and you have a lot of endpoints where you lose a little bit the visibility, and you end up centralizing them. So you end up using a layer 3 network to use a layer 7 network. So VPC Lattice was born to simplify that. So you can think of it as any use case where you use private link currently, you can look at how to simplify with VPC Lattice because it's the same principle that we are using. So it's different data plane, but the idea is private link 2.0 at the end of the day. So I'll come back to you, but Cristobal, how has it been so far? Where are we going right now in the code?
Yep, so if we come back to the architecture, just 1 second before jumping back to the code, the things that I've been building or coding are in this case, the service too. Just not only the creation of the service and the target, but also its integration with ECS, making use also of the module of ECS and its integration with VPC Lattice, so that when the new tasks are created, VPC Lattice knows where to target these requests that are coming to the service, and also as we were saying at the beginning, the VPC association. So if the code compiles, which it has done. Now, what we have, by the way, this is the QR code that we were sharing before. These are the 3 different calls that we have. One is for the service 1 on EKS that still hasn't been built. Then we have also the service 2 through the EKS, and then we also have the ECS service. So if we check, we haven't checked before on live, but as we can see that since there's no service 1, at the moment, the Lambda function is not able to resolve because there's nothing to resolve to, let's say. Same when we're making the code to the service 2 through the service 1. And now that, perfect, now that we're making the code to the service 2 that we just built and compiled, here we can see the code that is being done. If you want to comment.
Yeah, so far, because we have not been signing anything, the only information we have is what's the service network, what's the target, what's the AP that it's being consumed. So we don't have much, it's good information, so we know which VPC was talking with which VPC. We will see later, once we add the sign-in, how you got more granular configuration. So we have service 2. I think we can go for service 1, right? That we are going to do it using EKS. You will see that we want to spend much time on that. We'll just show you how to do it in the gateway controller. Definitely we can share or we can tell you more or less pages in EKS, in the EKS world where you can get more documentation about that. So yeah, so we have it in I think it's the EKS part. So we have. So I think the service is already created. What we need to do is just to create the VPC Lattice service. In that case, we're just simply telling the gateway controller that that our VPC Lattice service network is that one, the one with the name Amazon VPC Lattice. We didn't have a really good imagination to put a name on that. And then in the gateway specification is where we define the specific listener or all the information about the VPC Lattice service. So you will see similar information we did with the backend too on ECS. But now it's for the EKS cluster. And then the same with the targets. In that case, we will have 2 targets, the /local and the /remote, that will go to different EKS services. One that it will just simply say hello from backend 1, and the other one that will call backend 2 to provide the information from backend 2. So, yeah.
And the way that we're going to be deploying these resources, in this case, instead of doing the deployment via Terraform, what we're going to be using is the proper Kubernetes itself and the Kubernetes API. So we're going to be creating the namespace, the 2 backends, and then these YAML files that we just went through are the ones that are going to be creating the resources themselves. So the service and the targets. So everything, all the life cycle is created through and managed through Kubernetes.
Yeah, so right now the gateway API controller, you need to install it as a service or in a pod. It's not part of EKS Automod, will come soon, so you can remove that configuration. And we're using pod identity, where that specific pod where we have the gateway controller, it has the permissions to create all the VPC Lattice resources. So the VPC Lattice service, listener, target, target groups and the inclusion of the pod IPs into the target group. So yeah, so we have some questions, so yeah, before, yeah.
So this has a little bit of similarity with service mesh, right, or AWS app mesh?
So AppMesh try to simplify the resolution, so knowing that this service is in this place. Here we're doing both things. So we are simplifying the network, so you don't need to worry about how to get there, like send me the packet and I'll get it to the different service. And then with DNS is where we're doing our service discovery, to put in those terms. So we are simplifying the network and using now DNS, because Route 53 is one of our more high available services that we have in AWS. So using it as a service discovery to just simply tell, hey, I know this service, come to VPC Lattice. Yeah.
Is there the ability for like our apps teams to generate the service but not to attach it to the network without?
Yeah, no, yeah, you can do it. So you can create the service, and then both the service network and the service can be shared via RAM. So they can create the service, and then you can share it via RAM, and then have a central team that is the one plumbing stuff or automating the plumbing. So yeah, so you can do both.
What about cross-account service discovery?
So for that, we don't have a specific feature. We have a solution built that I built with a colleague, where we use simply Route 53 profiles. So you share the profile, and then what you do from the central account is you catch the new services are built in your organization, and then you create the resolution, and then you update the hosted zone. So we're building that, but for now, this solution is work pretty good. It's just even bridge, send it to a central account, you build everything with a step function, and then everyone get that service discovery. But yeah, but we're building it natively in the service. Yep. So we have some questions there. Yeah.
Besides the questions, the authorization layer, is there a way to like proxy custom pair token across VPC Lattice without doing some weird thing?
Can you repeat? Sorry.
Yeah, like the signed request uses the application header, right, as a bearer token. Is there a way to like proxy an additional bearer token from a user workload across that without doing some sort of custom header translation on the other side of the platform?
So you mean like not changing the application and still have the sign-in working? Yeah. Yeah, so for EKS and ECS, we have seen a lot of customers using sidecar proxies, which are the ones doing the sign-in. So you just simply like, before you send the packet, you just send it to the sidecar proxy, which is the one doing the sign-in. And then depending who's doing the call, it will use the specific IAM role for that. And then we'll put the header, and then we'll send it out. But
that would use like a custom header translation. So like my client is using a bearer token, and I'm passing them as an authorization header.
so you can have both. It's just like you will see that in that headers, you just need a specific headers for VPC Lattice. You don't need to change your headers. So VPC Lattice will check those. You can have extra headers if you want to do more authentication in your backend service. So you can have both authentications if you want to.
But I think maybe I'm misunderstanding how it works. Like the middleware of the service that gets the request on the other end of it is going to check the authorization header, the bearer token.
No, it's a different header for a specific. We will see later once we do the authentication, the specific headers VPC Lattice checks for the authentication that are meant for VPC Lattice. So if you have other headers, authentication headers or tokens, we won't touch them. We won't change any headers, and then you can still get them and have your own authentication in your application. As well, some customers, they don't even use signing, and they use their own tokens to do authentication and just simply do a pass-through of the communication. So yeah, so both are valid. Yeah. Cool. So how are we going so far?
Yep. So now what we have done, if we move first to back to the architecture, what we have done is deploying the service one in this case through AKS with kubectl. It has created the VPC Lattice resources that were needed for the communication. And so once we get back to the application, we had before non-resolvables on the service one and the service two through service one, because also we didn't have the DNS record on the VPC of the front end for the service one, which was also added via the code. And now we can see that we have communications from the Lambda functions to the AKS service. As you were saying, these are the at the moment it's being signed, but we still have some headers added by VPC Lattice, and we receive this hello from backend one by AKS. And in the inherited code that goes from the front end to EKS and then to ECS, we see the information of the first call being done to the EKS cluster with the headers that are received, and then the service 1 to service 2 communication call. In this case, we receive a hello from backend 2 powered by ECS Fargate and provided by EKS because it's in the middle of the call, which is different that, for example, when we call directly service 2 with the Lambda function, we just get the hello from backend 2 powered by ECS Fargate, but without the interaction of the middleman, in this case, the EKS service.
Perfect. So we have communication. So now we're going to add the security piece. Can you come back quickly to the slide so I can show?
Yeah, absolutely.
So what we're going to do now is quite simple. It's just we're going to change the policy that we had in the service network, and we're going to put a specific policy to only allow authenticated requests and only from our organization. So you will see in the code, it's just a simple JSON document. And then after we do that, we won't have any communication, so we will need to sign both the request at the Lambda function and at the EKS service, the one that is the remote EKS service. And once we do that, we will have the communication again, but now with everything authenticated. And then also, we will put, I think we can do it at the same time just to, or maybe a little bit later so you can see the changes. We will put another policy in backend 2, where now we are only allowing backend 1 to talk with backend 2, so the front end can only access the ECS service via the EKS service, the one that is in the /remote target. So whenever you want, you can come back to the code.
So I just applied this policy to the service network, which is in the middle of everything. Like all the calls are going to go through the service network, and in this case, this only from organization policy, as Pablo was mentioning, it's a JSON document in which we have in this case that the calls cannot be anonymous, and also the principal org ID must be the organization that we are using in this case. So now, if we come to the different calls, we can see that because we are not, this one's still cached, but in this case, we can see that we're getting the forbidden calls because we're not doing the signing of the calls.
Perfect. So now we can go and do the signing. Both now
It's working.
So both in the live code, so things can be wrong. Don't worry, like it may happen.
Who thinks we're not going to have any issues while deploying the whole application?
We don't have any issues. Recorded demo that proves.
What's the worst thing that you can do in a demo?
Yeah.
Doing it live and not having a backup plan. So.
Exactly. But yeah, so now we're just simply signing the request. You will see that there are just like some lines of code where we're just calling the SIG before endpoint, getting those signed headers, putting in our headers. The only extra header we need to have in VPC Lattice if we want to use the SIG before authentication is we cannot have sign also the payload. So we need to send the header of unsigned payload and then the signed headers. And that will just simply send now the new request with the signing to VPC Lattice that will get us the signing done. So by the way, we're using, as you can see, Cristobal is not typing almost anything because we're using QCLI. That also helped us build the demo, I have to say. So also it's good to have the QCLI or the Q add-on in Visual Studio to help us do in the code. So then like something to say while Cristobal is adding the code is, I mentioned before that you can put the policy, and we're putting the policy in the service network and in the service. So one question can be, where should I put a specific policy in one of them? So usually the service network is owned by a network infrastructure administrator or the security team, depending the different organizations. So the service network will have, the recommendation is to have the policies for the guardrails of the communication. So only sign request, only from the organization. If we have a specific service that is quite important, we can put the granular policy there. So we put the minimum security that we want in the environment. And then in the services is where each service owner can have extra security mechanisms. So they can say, hey, my service can only be targeted with GET requests, or my service can only be accessed by this specific team, so I know exactly their namespaces if they use EKS, their IAM roles if they use Lambda or ECS. So it's kind of like a layer security when we democratize a little bit the communication or the access communication. And then when we do the signing, we use 2 different endpoints for SIG-before. So right now, are you in the EKS, right?
EKS one.
Yeah, so in the Lambda, I think we're using the SIG-before, normal SIG-before, which we bound to a specific region. So if we sign the request with the normal SIG-before endpoint in that region, and then we try to access a service network in another region, we're going to get an error, because that service network won't know how to obtain the metadata, the security metadata. So I think in the EKS, we're using in SIG-before, the SIG-before asynchronous, which we can use in any region. So usually customers ask which one is better. If you have use cases of cross-region, definitely use the asynchronous one, because you can sign whatever you want to and then have your services authenticated in the other region. So yeah, so how we're going?
Yep. So far, what we've done is compiling the Lambda function again, and we have updated the Terraform code. Now we are building a new image for the EKS cluster. And now what we're going to do once we have the image, we're going to do the redeployment. So both the Lambda function and the backend are updated to make the signature code.
So while we do the redeploy, any questions? Yep.
How is the Lambda VPC getting associated to the service network?
It's just so the association. I would say it's kind of like the gateway endpoint. So you don't put ENIs. We put ENIs, but you don't see them.
Is there an endpoint then?
Yeah, when you create the VPC association, then suddenly you will see like access, or you will see like some route tables point the link local addresses to VPC Lattice. And then there are some ENIs. Then if you use the service network endpoint, yes, you control the endpoint, but the VPC association abstracts everything there. So you do the association, and then suddenly we create ENIs that we manage completely, and you don't need to worry about the communication, because it will be a link local address, unique local address for IPv6, so it will send the packet to VPC Lattice.
And I see that there is like a source VPC header that is being
Yeah.
sent.
And that's the VPC that is doing the call. So it's like the Lambda VPC or the EKS VPC. Yeah.
Right. And I believe you can use that as a condition.
That's one. For example, that's one of the things you can put in the policy. If you only have one Lambda, that's perfect. You don't need to sign requests. But for example, if you have an EKS cluster and then you say, hey, I want this namespace to make the calls, but this one I don't want to, that's where you do the sign-in, and then you get the information about the specific namespace. You can use both identity.
Is there a VPC ID as well?
If we were using the service network endpoint, you will also see the service network endpoint ID as well. So yeah, so you can also use that metadata information. Yeah. Yep.
Maybe a follow-on question to what he asked and what you just answered. If we already have a pod identity, I mean, every Lambda, every ECS task that's part of this has their own IAM nodes, can we just use those proxy instead of doing SIG-before signing at each?
Yeah. So for example, we have seen that, VPC Lattice, you just simply connect everything, and then you use your own, for example, AWS verified permissions, like we have seen some customers using, where you do your own auth C in the application for that. Yeah, that's a valid one.
I guess I mean, do we have to do SIG-before signing?
Yeah, you need to do the SIG before signing. If you want to do the capabilities within VPC Lattice, yeah. Currently, the only option is doing SIG before. There's no other way you can pass the credentials to VPC Lattice in another way. Yeah.
So I can't use the IAM that's already attached?
You can use the IAM role that is attached, but you need to sign with SIG before, so SIG before can put the information, the IAM information there. Yeah. So all good?
Yep, I surprised myself every day even more, and it worked on the,
on the first one.
First run. So
yeah, it didn't happen yesterday, but yeah.
What we can see here is that the signatures that we were adding are adding some headers, which don't delete the headers that we might be using already for, as you were saying, authorization token or whatever to identify our users within the application code, for example. But in this case, Lattice is through the signature we're adding these request headers at the beginning, and what is received in the other side, we can see that now we have a lot more information about who's making the call regarding the principal, the source, VPN, so the ARNs, the principal organization ID, that now this was the conditions that we had in the policy that didn't allow us to make the calls before because we were not doing the signature, and now we have even the organization ID, the session name, all the information that we get from the signature itself.
As you can see, what I was saying before, that the headers, there are specific ex-Amazon Lattice headers. So you can have two different ways of authorization. You can have a minimal authorization to the network and then add your own application authentication if you want to.
I think that's what we did. We were checking for the 64 authorization header in Istio for the authorization policy there to make sure that
Yeah.
VPC allows to make sure that for that specific gateway and that specific set of resources, we would only want accepting those VPC
Yeah.
policies, nothing else.
Yeah, and then, yeah, exactly.
Is that available across the region, or how does what key is it using to do the verification for the signature?
Don't know, to be honest. We'll need to check that. I'm not sure. And then now what we're doing is we do the allow EKS role. Can you show it? Yeah. So that one is really, really granular because you can see that we're not putting the resource itself because we are already putting that policy in the backend to service. So we don't need to explicitly say which service it's going to be on that one. But here what we're putting is the EKS node group IAM role. We could have been even more granular with pod identity and have a specific pod or a specific namespace, specific IAM role. But in that case, we only did the node group. But yeah, you can have a specific information there to do the authentication. So now the first call and the second one should work, but not the third one.
Let someone say which one should work. And
I already said it, but yeah. Sorry about that.
You were too fast.
Yeah, I went too fast. But yeah, so basically 1 and 2 should work. But then the second one should be not allowed, even though we have the organization. So I think if I can come back quickly and put the, let me come back in the.
Wait, I'm gonna give you the screen.
Yeah. So when I explain the security, so yeah, in that one. So as you can see, is now what happened is in the use case. The packet went to the service network, and they were like, okay, it's part of the organization, it's being authenticated, I send the packet. But then when I arrive to the service, the policy in the service, it's saying, hey, your principal information is not the one I'm expecting, so I'm blocking the traffic. So that's why I said, like, even though you as an administrator of the network say, hey, if you're comply with these security requirements, packets will arrive, but maybe the owner of the service, they want to protect more the application. So then the typical of, hey, I cannot connect, this is the network's like, no. Go talk with the other guy so you can see in the logs that, hey, the problem was not authentication, so check that you as a consumer comply with the security requirements or talk with the other service owner to check that if you have permissions or not to consume that specific service.
So in this case, we can also think about like when doing troubleshooting, for example, we're used to checking routes, checking IP addresses, checking permissions, like who should go, where's the call being lost. In this case, we would only have to worry only about DNS resolution. Can we resolve or not? And once we have the DNS resolution, are we allowed to access the service or not? And if not, why not? Is that something because we're not making the signatures and maybe that's something in the service network, or is that something specific to the service? And just with a couple checks, we're troubleshooting all the communication from consumers to the services.
Yeah, and I think with that, basically let's do a summary of what we have done. So we first enabled the communication with the association of the consumers, publication of the service and the association. And then we create the DNS resolution. By the way, with EKS, we can also create the DNS resolution. We just did it using Terraform to simplify our lives a little bit once we have created the the VPC Lattice service. And then after that, we added the security. So we put it, these two policies, and we signed the request to be able to consume the different services. So let me come back to the proper piece of it. So yeah. So with that, any final questions from your side? Yeah.
I already answered it, but I maybe struggle to understand. So clients coming in, they're not going to be signed or anything. So how do we take that and allow other external connectivity into the network to access their services?
When you mention external connectivity, is someone outside of AWS or kind of like a new?
Like an ingress from the internet?
Yeah, so we have patterns for external connectivity. So we have another solution that it's an Nginx in an ECS that is doing the, okay, come to me, and then I'll take you to the service network. You can use things as IAM roles anywhere to sign the request in the consumer. So you can use that to sign the request with SIG before, get an IAM role from your certificate, and then this proxy layer will just simply get you to the service network. But the thing is, like, usually this is more for service-to-service communication within the organization environment. So the most common use case is hybrid, maybe, where we have the endpoint. So you can use IAM roles anywhere, but then you will connect to the service network endpoint via Dark Connect, VPN, or everything.
Fall back to just standard IP connectivity for ingress patterns.
Yeah, you can also do that. Yeah, exactly.
And is there a way for things like ECS to sign on behalf of the service rather than have to sign it at the application?
Yeah, that's what we said. Like in EKS and ECS, not Fargate, you can put a sidecar proxy. So you can give them the capability of a sidecar proxy doing the signing. Ideally, with majority of those customers, like, try to end up in the situation where it's the application the one signing, but you can provide the sidecar proxy while these applications are moving to the new code. But yeah, like, the sidecar proxy works. Usually feedback from customers is, for example, if it's a Lambda function or things in ECS Fargate, they can quickly sign the request, change the application, and then do the signing. Yep.
I might have missed, but would you be using VPC Lattice and then, let's say, maybe using Istio or something like that for service mesh?
You can do it, yeah.
Or would you recommend, because I don't think VPC Lattice gives you the same capability.
Yeah, exactly, it doesn't. So for the use case of Istio, and then you want to extend your Istio into cross-cluster, what VPC Lattice can provide is the simplification of the connectivity between those two clusters. But still, you can use Istio on top of that for the extra capabilities of that. Some customers say, hey, what Istio provides me now, it's good because I'm using like a simple way of doing Istio just for the service discovery and simplification, so I can move to VPC Lattice. Or, yeah, I just use VPC Lattice and then I still use Istio for the rest. Exactly, so VPC Lattice helps into that, okay, let me connect things that are in different accounts, different clusters, and then you can still use Istio for the rest of the configuration. Yeah.
So for bidirectional service, like, we talked about service B2B. Is there anything specifics that we need to always
You just simply like do the two VPC associations, you publish the two services, and then you enable DNS resolution. So that's the bidirectional communication. So you will see majority of the diagrams like point A to point B because it's simple to show it, but at the end of the day, it's like you just connect your consumers and your producers, and then you just enable the DNS configuration. Or connect that and then have things like Istio helping you also in that service discovery and extra capabilities. Yep. So yeah, I wonder.
One of the things we've seen with adopting it that caused a lot of support problems is the code for signatures. Do you know if they're planning to update Photo 3 or any of the libraries to make that easier?
Yeah, so we're working on that. Yeah, that's been a common feedback on that. Yeah, we're working on it to simplify that piece. Yeah, definitely. I cannot tell when, but yeah, like, it's something that, yeah, I know the team is actively working on that. Yeah, perfect. I think we have, yeah, almost 5 minutes. I think we can get 1 or 2 questions, and then we can close this session. So yeah.
So you did an exercise where you went from essentially an unauthorized sharing of resources to an authorized one, and that's great that the capabilities there. My question is, I'm not talking a lot about in terms of visibility, like your CNAP
So we provide the logging capability. You can send it to S3, to CloudWatch, to Firehose, to send it to another HTTP endpoint. What we don't have is this automation to do some logic on the logging capabilities. But yeah, we are working with customers on things like, hey, we have a service doing a lot of unauthenticated requests to notify, do some sort of like automation to make sure, okay, what's happening there. Or even the other way around. We have suddenly guard duty is telling me that my service in the cluster is doing something funny. So what I will do is maybe to put like only a policy to block traffic from that service only and notify the different people saying like, hey, something is happening. Guard duty is telling me that you're doing something that we don't allow. So we cut you access to the key application just in case, and then we will come back to you. So you can do a lot of automations now on VPC Lattice from the logging information. We don't have any plans so far into building them, but yeah, we're open to get feedback. Yeah.
Basically, they're coming and have posture, so they don't have visibility into how they're doing that when they need the type of help like a CIS.
Yeah.
Is that being thought about?
Yeah, it's been thought. Yeah. We've been discussing even with the security hub team and all this security service team how we can integrate it. But yeah, so it's been thought. It's just like, of course, like we need to put a lot of people together. But yeah, it's something that definitely any feedback will be more than welcome on how to make VPC Lattice, because we have been focusing a lot on the configuration, the connectivity, but also on the security piece. Perfect. So yeah, so for the remaining ones, you can come back after we close because we have only 3 minutes. So we wanted to do kind of a summary of everything, and then we can have a chat. So in terms of considerations, the first one, what we want us to take you after this session. So the first one is the simplify the network environment to enable agility. We see a lot this fight that the security and the networking people are the bad guys because you don't enable the developers to be agile. So services like VPC Lattice enable you to do that without losing security. And also work backwards from your internal customers. Understand what are their needs, how you can simplify their lives, and how you can make sure that they can work as fast as they can while you provide these security mechanisms.
Yeah. Besides, as all of you have mentioned as well, like most of you have several hats or several roles at some point. When thinking about security, it's the way we see it is not only security in one place, but security is a bunch of layers that add up, and all of them are important. So in this case, we're aiming as well for shared security. We have, as we have seen, the service network in which we have the security that can be applied for more of an across organization or across services, identification needed, for example, or signatures, etc. But we also give the capabilities to the development teams, for example, or the teams that are exposing the services to decide the security that they want, more granular maybe, for example, into the service. So we can have both the services being exposed and the service network applying the security. And finally, you have seen us working with infrastructure as code. This is the way we really recommend you to work on AWS in order to scale, to avoid manual mistakes, to really grow into a production stage and allowing you to, for example, leverage the things that we have used by taking the code that we're using and improving or iterating from there. So there's really a lot of advantages on using it. So we really encourage you to use infrastructure as code whenever you can.
Yep. And just to finish, again, the VPC Lattice blueprints, we will be updating even more with more use cases. All the part of EKS and authentication will be included in the following weeks. I think now what you have is an example of multi-account. So you can see an example of RAM share and how you can work with VPC Lattice in multi-account. So with that, thank you very much. Please give us some feedback about how we did it. If you want this code talk in a different way in the future, Reinforce and even why not in Reinvent. And yeah, you also have VPC Lattice stickers in the black table where there are the audition machines. So you can also take some. I don't want to take them back to Madrid, so please take as much as you want. And yeah, enjoy the rest of Reinforce, and thank you very much.
Thank you, everyone.